Okay, so with this induction, so I know true for n equals 1. So it's 1 times 1 factorial will equal 1. That's the left-hand side. And the right-hand side is 1 plus 1 factorial minus 1, which is 2 factorial minus 1, which is 2 minus 1, which is 1. So that works. Then we're going to assume for n equals k. So that's 1 factorial, plus 2 factorial, plus n, plus k factorial, equals k plus 1 factorial minus 1. And then we're going to prove for n equals k plus 1. So that's 1 times 1 factorial, plus 2 times 2 factorial, plus k times k factorial, plus k plus 1 times k plus 1 factorial. And we want it to equal k plus 1, which is k plus 2 factorial minus 1. Okay, so that means that the left-hand side is made up of adding k terms, so that's the sum to k, plus the extra term, the tk plus 1 term. So the sum to k terms, which is this, we assume is true from the previous one. So that's k plus 1 factorial minus 1, and then plus a term in k plus 1, that's this one here. That's k plus 1 factorial. Okay, so I'm just going to rewrite that. So that's k plus 1 factorial minus 1 plus k plus 1 factorial. And our aim is, this is our prize is k plus 2 factorial minus 1. Okay, so when we're looking at this is the left-hand side. It's probably good to put this here. Like, don't worry about the 1. Put the 1 at the end, because the 1's at the end here. K plus 1 times k plus 1 factorial minus 1. Now the key here is to factorise this. So the common factor here is k plus 1 factorial, and then you're looking at what's left. So this one here, that's k plus 1, so there must be a 1 left, because one lot of those gives you k plus 1 factorial. This plus sign in the middle will remain there, and the second eyebrow will be for this one. So if we take out a k plus 1 factorial, we'll have k plus 1 left. So that'll be k plus 1 factorial times k plus 2 minus 1. So that's going to be k plus 2 times k plus 1 factorial minus 1. Now k plus 2, k plus 1 factorial is actually just equal to k plus 2 factorial. Because if you think about it, k plus 2 factorial is k plus 2 times k plus 1 times k minus 1. So you just keep taking 1 away. So this part here, that's k plus 2. This part here is k plus 1 factorial. So you can pull that in and it just becomes k plus 2 factorial. So this is basically k plus 2 factorial minus 1, which equals the right-hand side proven. Therefore, by the process of mathematical induction, it'll be true for all n greater or equal to 1.